The next thing that I want to do in geometry is to study or go with you over the right triangle trigonometry. Now, the word trigonometry literally means triangle measurement. So what we're going to be doing then is using this right triangle trigonometry, we will be finding lengths of sides of a right triangle and measures of the angles of a right triangle. But a right triangle has two angles that is not a right angle, and they're called acute angles. So the acute angles of a right triangle are complementary. And complementary angles are two angles, the sum whose measure is 90. Now, also when we're talking about a right triangle, the sides are denoted by lowercase letters. So if you look at my diagram, A, B, and C are sides, and they're lowercase c. The angles use capital letters. So if you look over here, this is capital B, and of course the right angle is always capital C in this case, and this is capital A. Now, the reference angle is the angle measure given, in other words, one of these angles will have a measure, or the reference angle is the angle measured to find. So when you work in trigonometry, or you work in right triangle trigonometry, you're going to be calling one of the angles the reference angle, the angle that we're referring to. So when we are talking about solving problems, when determining measures of the right triangle, a person begins by stating which angle is their reference angle. Now, in this particular right triangle, there are two angles that we do not know the measure of, or there's two angles that we will know the measure of. So we need to state which one are we referring to. And so that is where we start the process off, is determine what angle is given, or what angle do you have to find the measure of. And now, but now for our purposes, or what I'm trying to say, for explaining how to use trigonometry, I'm going to put angle A now will be the reference angle. But angle B may be called the reference angle. But when you work in the problems, that you need just one angle being called the reference angle. Now, when you're doing the right triangle, and say in my case here, I have placed A as the reference angle, then we need to name our sides. Well, the side opposite the right angle here will be the hypotenuse forever. But if my reference angle is angle A, then the side away from angle A, we call him the opposite side. Now notice that the capital A uses the lowercase a as the opposite side. You always put that case. So now we have the name of this opposite side is the one away from our reference angle of A, the hypotenuse. So we need a name for this third side, and he's called the adjacent. So you need to learn that that's what they are. Now, if you change it up and use B as your reference angle, this is what's going to happen. If you use B as the reference angle, then this side away from him would be called the opposite side. And so you have to be careful in knowing which angle, because if he's the opposite, then he's the adjacent side. And you have renamed the sides because you used a different reference angle. So we don't want to have two different reference angles. And when you work your problems, you won't have to run across that, because you'll be known, or you'll be told to find either the angle A or the angle B. Now, I'm going to have to make a little adjustment here so I can read this off of here. What we're going to have is some trigonometric ratios. We're going to write a ratio when we're solving for trigonometry. And a trigonometric ratio is a ratio of the lengths of the two sides of a right triangle. Now, the three basic ratios are sine, cosine, and tangent. So here we go. We're going to have this ratio. Now remember, angle A is my reference angle. I'm using him. So this side away from it is called the opposite, and this side is the hypotenuse. So when you write the ratio of opposite over the hypotenuse, then the name of that ratio is sine. And when you write the ratio of the adjacent side over the length of the hypotenuse, that's the cosine of angle A. Now you must understand, if you use the word cosine or sine or tangent, you've got to have a reference angle. And our reference angle is A. That's the angle that we are speaking about. Then you go to the third occasion. Now if you'll notice, we used the hypotenuse twice. We have not used the opposite and adjacent twice. So if you write the length of the opposite over the length of the adjacent, then that name is tangent. And that information is what you need to practice on, that you need to learn. You have to learn this setup, that the sine of some angle is the ratio of opposite over the hypotenuse. The cosine of some angle is the ratio of adjacent over the hypotenuse. And the tangent of some angle is equal to the opposite over the adjacent. You have to learn those. You can't refer back and forth to them. You need to learn that. And of course, till that day happens, you'll be able to refer back and forth. But eventually, in other words, if you were in class, I would say get out one sheet of paper, and you're going to tell them, and you're going to write, I'll say, what is the sine of A? And you would write the opposite over the hypotenuse. You'd have to learn that. You'd have to memorize it to a point of time that is knowledge. But you're no longer memorizing it, you know it. Same thing with sine, cosine. What is the cosine of some angle A? Adjacent over the hypotenuse. And I say, what is the tangent of A? And you would write opposite over the adjacent. Those are the length of the sides of a right triangle. Now, we don't write these words out. We abbreviate, and the abbreviation for sine is S-I-N. Not sin, but sine. When you abbreviate it, you still got to repeat the word. Now for opposite, you would write OPP. And hypotenuse, it's just the first three letters you'll notice. Cosine, COS equals abbreviated ADJ HYP. And then tangent is not tan. You're not allowed to say tan A. Now some people may eventually start that, but not yet. So this is the opposite over the adjacent. And there are three other ratios that we can write, but these are the three that you find on your calculator. So that's why over here I say to you, you will need your calculator to determine the answer to these problems. And of course, when it comes time to calculate them, I'll have to put a little time on showing you how to use your calculator. So here's what's going to have to do. We're going to work some problems now. And there's a few requirements first. You must be given an angle and the length of one side of a right triangle to determine the measure of the other side or sides. There are three sides in a triangle, but sometimes you're only required to find one side. Then sometimes you're required to find all the sides. Or if it's not that scenario, you must be given two sides to determine the measure of an angle. Now remember, the acute angles of a right triangle are complementary, and that means that the complementary is two angles, the sum of whose measures is 90. So let's see how successful we are with a few problems. Now, here we go. We are given the measure of angle. Now, it's 44. Now, the side that has the x in relationship to the angle 44. Now, we're going to call this the reference angle now. That fellow is the reference angle. He's the angle measure given. So we call this side over here in relationship to 44 angle as the opposite side, abbreviated OPP. Now the number side is the side opposite the right angle, so we'll name him as the hypotenuse. Now up here I say for you to always start with the reference angle. So we're going to write 44. And we're going to write a ratio. Now, if you look at what we have the length of the opposite side to find, and we're given the measure of the hypotenuse. Going back to this other, if you put the length of the opposite over the length of the hypotenuse, that's called sine. So, we're going to put the length of the opposite side over the length of the hypotenuse, and that would be, well, I don't know the length of the opposite side, and I know the hypotenuse is 15.8, and that ratio is called sine. Now it's calculator time. We're trying to determine what is the value of x. Now go back and think very carefully when we was talking about proportions. And that was cross multiply. Now, but here's how you need to put it on your calculator or on your next line, whatever you want to do. X equals. Now, I would say to everybody to always put next the measure given, or in this case, the measure of a side, and then multiply it times the sine of your angle. And So, if you do that arithmetic, you will get a pretty long number, 15.8 times sine 44 equals. Now my calculator says it's 10.97560225. Now I put all of that for purpose. We can keep all those numbers, but at the same time, we have to round off to the correct number. Now, on this board, the paper I have placed, rounding off, it says your answer cannot be more nor less precise than the measure given. Now, what that means is, if you look at 15.8, the measure of the given side, which is 15.8, has only one place behind the decimal, which means your answer must be rounded off to one place behind the decimal. And so, I hope you remember how to round off. You want one place, so underline that one place, and then put that parentheses there to tell you that all these other numbers are gone. But before you start throwing all of those numbers away, you must check that 7. Is he 5 or bigger? And the answer, of course, is yes. So what you would do is you would add 1. Let me go over here to add 1 to 10.9, and so that would be x equal 11.0. And that's how, and that's approximately, when you round off, you have to put approximately. Now people, that's going to take you a few shots, I believe, before you can really pay attention to that rounding off. If your number only has one place behind the decimal, then your answer can only have one place. Now, of course, everybody would be saying, well, isn't 11.0, isn't that kind of understood? Can we have that, leave the 0 off? No. It must have the point 0 because of the precision of your measurement. You are saying if you're close to point 0 means how many tenths that is. And so that's how you accomplish the problem. Let's try the next one I have here. To do him. Now, 67 is the angle measure given, so that's the first thing you write. Is you write the angle measure given. Now, I couldn't put the degrees on my board here, but it is. Now, the side it had, now remember, this side over here is the opposite. Okay, we don't have the length of the opposite this time. Now, he over here is the hypotenuse. That's the side opposite the right angle. But what would you call this side that has the x is the adjacent? So we have to find the adjacent side, and we are given the hypotenuse. So going back, if you have the adjacent, you write it over the hypotenuse. So, I'll write a ratio of the adjacent over the hypotenuse. Now, what is that called? And of course, that's cosine. So you put the cosine of some 67. Now, what is the length of the adjacent? I don't know. What is the length of the hypotenuse? 107. Now, we're solving for x. So x equals, now remember, I always ask the students to put the measure of the side given. And that's through experience with the calculators. So if you'll do that and you keep that every time, consistency is very important. Now, so you multiply 107 times cosine of 67, x is approximately 42. Now notice this time I do not have a decimal behind the 2 because this 107 over here did not have a number behind the decimal. So your answer has to match out. If you're given no decimal, the answer must not have a decimal. Now that may take a while to understand. And remember that you always start by writing the reference angle. That's the angle that you know the measure of, or that's the angle that we need to determine. Now I've got another one here. Now, again, we're given 41. That's called my reference angle. So that's the first thing we would write. And we're going to write a ratio for trigonometry. Now, over here, this side is called the opposite side because he is the side away from 41. Now, this side is the hypotenuse. We don't know that, or nor are we trying to find. What we're trying to find is his third side, and he is going to be called the adjacent. So we're trying to find the measure of the adjacent side, and we're given the length of the opposite. So our ratio would be opposite over the adjacent. Now, I'm using the fact that what I showed you earlier, that if you put the opposite length over the adjacent length, that is the tangent. So, that's tangent. Now, over here, the opposite is 4.9, and the adjacent is x. Now we have a little different scenario here on this side here about a calculator. Now people can show you two different ways, and I'm going to show you two ways here, their way, and then I'm going to show you what I would like for you to think about too. Of course, you cross multiply, that'll be x tangent 41 equals 4.9. Then you would divide by tangent 41. Now, so you would go to your calculator and you would put in your calculator x, of course we're looking for that, 4.9 divided by tangent 41. And so that is the process that you need to consider on this type, and x is not on top. And when I did it, I got the answer to be 5.6. Now, why did I round off here to one place? It's because 4.9, if you look back over here in the diagram, has one place behind decimal. And that's how you determine what to round up. Now that's an example using tangent and then cosine and sine. And of course we were looking for a side. Now the next setup is now let's determine the measure of an angle. Now angles use capital letters. So if you look at my diagram, I have A there. Now the other angles don't have one, so that means I'm trying to indicate that emphasis, I want to know the measure of angle A. So I'm going to put my little parentheses to indicate that one. Now we don't put another letter of the alphabet, like for instance X. We put A, or whatever the angle has this. Now, well, this side is called the opposite side. Of course, this side is still called the hypotenuse, but the side that we have here is the adjacent. Now, so we are looking for an angle. We do not know the measure of the angle, but we do have the hypotenuse and we have the adjacent. Now the ratio that uses adjacent and the hypotenuse says the adjacent is on top and the hypotenuse is on bottom. That is called cosine. Now what is the adjacent side? 13. What is the hypotenuse? 46. Now, young people, when you start looking for an angle, you got to realize that we don't do it the same way when we're looking for a side. So if you watch carefully, the first thing I want to write is the angle that we're looking for, in this case angle A. Now, your calculator has a second button above the cosine. So if you'll do what I'm showing here on your calculator, you'll eventually start seeing the answer. So push at the top of your calculator the button that says second. And then this cosine, push cosine. And when you look at your calculator, it's going to open up a parentheses. Now, inside that parentheses, put our problem of 13 divided by 46. And push equal. See, when you're looking for the angle, we use the second key on the calculator. And so if you take and push second cosine and fill in the parentheses with our problem of 13 divided by 46, your answer rounded off is 39. Now if you look up here, we don't have any measure of an angle given. So when you give an angle, we just round it off to no places behind decimal. So the answer is 39. Now if we was having class, I would show you how to do degrees, minutes, and seconds on that calculator, but I'm not going to put our time doing that without looking, because it takes a while to understand, first of all, what are you talking about. Well, anyway, that's how you do number 4. Now, number 5. Now again, you always start with your reference angle. Now in this case, I've got A down here again, so that's the angle that we're trying to find. So you write the angle first. Now we're going to have to write a ratio. Now, in this setup, this side that has the 8.7 would be called our opposite side. The 13.8 is the hypotenuse. So we have the given the measure of the opposite, and we are given the measure of the hypotenuse. So we want the ratio that has the opposite over the hypotenuse. And of course, we know that, or should begin to learn that, is sine. Anytime you write the ratio of the length of the opposite over the length of the hypotenuse, that is sine of your angle. And then the opposite is 8.7, and the hypotenuse is 13.8. Now, remember, please, we are looking for an angle. Use second key. So what I'm trying to say to you, you would write angle A. We're looking for angle A. That's angle A. Is now second. You look for the second. You're looking for the angle. So you put second sine, and it'll open a parentheses. If your calculator's like all of them, it's going to have a parentheses. Second sine, and put in your calculator 8.7 divided by 13.8. And equals. So put sine, second sine. Now it open that parentheses open and put 8.7 divided by 13.8. And my calculator said 74 degrees. Now it is rounded off to no places. You do no places on angles. You look back up here and you say, well, he had one and he had one. That's sides. Those are sides. We're talking angles. And angles, I want you to understand we round off to whole numbers. Next, we're looking for an angle again. And so we always start with the reference angle. So angle A equals, then we're going to write a ratio. Well, over here, this fella is the hypotenuse. This side is called the opposite. This side is the adjacent. So, we're given two sides. One's the opposite, and one's the adjacent. That means you put the opposite over the adjacent. Now, you could put adjacent over the opposite, but if you go back to our basic functions, which one of them is adjacent over the opposite? Well, he's not. This is the opposite over the adjacent. Now, we do have a name for this. This invert is called cotangent. But we're not doing cotangents. We're just doing sine, cosine, and tangent. Cotangents is for your next level of trigonometry. Now, so let's get back to our problem at hand. So we have the opposite over the adjacent, that's called tangent. And so we have the opposite is 3.8 over 10.5. Now we're ready to solve for the angle. Now remember, when you're looking for the angle, you use the second key for tangent. Second tan. And inside that parentheses, put 3.8 divided by 10.5. And the answer that you should come up with is approximately 20 degrees. Okay, there's 6. Now let's try this last one. Now, again, we always start with a reference angle. But young people, this is a two-part question. You got two things to accomplish here before you get the answer. Can you handle it hoping that the answer is yes, sir, I can do it. Now, the problem is to determine this x over here. Now, if you look at this triangle, I'm going to show you it in blue. This over here, now that's the altitude right there. Now, that's not a right angle. Because see, 51 and 45 does not add up to be 90. They're not complementary. So 51 and 45, so that doesn't make this angle a right angle. But anyway, finish up with the blue triangle. Okay? Now, we need to find a side. Now, earlier I told you, to find a side, you must be given the length of another side. But there is nothing here for that blue one, and for that blue one, and this blue one. There's nothing given. So that pretty much is on hold. So what we need to do then is to find one of these sides. And now what I like and hope you see, that this side we have called the altitude is the same altitude to the triangle on the other side. So this altitude of both triangles is a common side. So what we're going to do then is to find out what this is in the radian. We're going to put our unknown for the altitude. Now remember, you start with the reference angle, so that's the angle given. We got 51 equals. Now here, he's the opposite side. Here, he's the hypotenuse. So we're going to write a ratio of putting the opposite over hypotenuse. Opposite, oh, that's x. The hypotenuse, 88. Now what do you call the ratio of the opposite of the hypotenuse? Sine. Now we're not looking for an angle this time, so forget about that second key. No, don't even think about that second key. We're not looking for an angle here. We're looking for the length of a side. Cross multiply. So x equals, now I like for people to always put the measure of the side, then multiply it times the sine of 51. I have found that helps a lot of times. Now we're going to round this off to 68. Now why don't I have a decimal? Well, 88 doesn't have one, but that's approximate. So this side that called the altitude will be 68. Now we've got to go and deal with the blue triangle. Now here in the blue triangle, our reference angle, start with the reference angle, is 45. Now we have, this side in the blue is called the opposite. And this side in the blue is called the hypotenuse. So we're going to write the ratio of putting the opposite over the hypotenuse. Now, to do that, then that's called sine 45. Now, okay, here we go. We got the opposite side is 68. And we've got the hypotenuse is x. Now, got a little situation here now. We cross multiply. That's going to be x sine of 45 is equal to 68. And that's a little different from what we just did. We're dividing here. I hope you're watching, paying attention. Like I'm in class, huh? X equals approximately 91. Now people, that I'm going to stop there with that video and have a second one that uses the word problems that go with this one. So this is going to complete this video.